So about a month ago I posted this video titled Destroying the Flat Earth Fairy Tale with a Moon from 43,000 feet. And just to recap, it was made on a flight from the USA back to Australia at night, where I was able to capture the moon as it was setting clearly below true level. Now that is obviously bad news for flat earthers because an observation like this would never occur on a flat earth. As a result, a number of flat earthers have gone straight into damage control mode and have attempted to discredit this video. So clearly the only way we can analyse the position of the moon is to know the precise location of the aircraft and the exact time the observation was made. And without that information, any analysis will be meaningless. For example, if we use the wrong date, the position of the moon will be quite different because, as we know, it sets at a later time every day. And that is why I had to laugh when I saw this video produced by a flat earther titled Checkmate Wolfie 6020, because that is exactly what he did. He used the wrong date entirely, and as a result, his analysis of the moon's position relative to the aircraft is completely irrelevant to my own footage. Let's now take a look at an accurate analysis using the precise aircraft location and the correct time and date. So as you might recall, I had to turn the aircraft to the right to position the moon in the head-up display, and I had requested permission to do so from air traffic control via the aircraft CPDLC system a short time earlier. There you can see the message requesting the right-hand deviation, and that was sent at 0540 UTC time on the 10th of March. So typically on longer trips, I take my Bad Elf GPS unit and allow it to run for the entire flight. And that way I can later import the GPS track log into Google Earth and replay the flight. As you can see, we departed the USA, we landed in Hawaii to refuel, and we continued on to Sydney, Australia. Now the log is so accurate that we can clearly see the point where I made the right-hand turn for the observation. And furthermore, we can get an accurate time as well as an accurate position. It was the 10th of March at 0558, just prior to commencing that turn. Our aircraft has an onboard Wi-Fi system provided by Satcom Direct, which gives us internet access all over the Earth via satellite. And that is one of the coverage maps. Now, because the aircraft is constantly in communication with the satellites, they are also able to track our position. And I was able to extract the flight path log from the Satcom Direct website for our trip. And there you can see, just prior to making that right turn, again, we have the 10th of March, 0559 UTC. In addition, we have very precise location information. So let's now put that into the Moon Calc website and see how the predicted position of the moon matches what we observed. So looking at the footage again, let's see if we can determine what we expect to see from Moon Calc. As you can see, the moon is below eye level, and therefore it is below the horizontal. And that means if we were on the ground at this location, the moon would have already set. So at that time, shortly after 0559, we should have the moon setting. And as you can see, the angular size of the moon is about ½ a degree, and it is just below the horizon line. So the center of the moon would be around 0.25 of a degree below horizontal. Let's take a look at that. So we're now looking at mooncalc.org, and I have entered the aircraft's position precisely. I have also set the date to the 9th of March and the time to 20:59 UTC-9, and that is identical to 0559 UTC on the 10th of March. And the first thing you will notice is that the orientation of the crescent matches the observation perfectly. And at this point, the moon altitude is minus 0.09 degrees. And this is just prior to commencing the right-hand turn. Let's see what happens a minute or two later. So 1 minute later, right on the hour, the moon's altitude is minus 0.25 degrees. That's exactly what we see here. Another minute later, the moon has set. Now remember, this is showing what would happen at sea level. The moon would disappear because it has set. The only reason we can still see the moon at high altitude is because the Earth's horizon has dropped, and the moon's position in relation to the horizon line on the head-up display again confirms that it is below true level, matching perfectly to what Moon Calc is showing us. So when we use the correct time, the correct date, and a precise location for the aircraft, the prediction in Moon Calc matches the real-world observation perfectly. And that's another easy win for the globe.